the entropy of a pure substance. Entropy is an extensive property of a system Values of a specific entropy per unit mass are given in tables of thermodynamics. Properties in the same manner as a specific volume and a specific enthalpy. And a specific enthalpy. The unit of a specific entropy in the steam tables, refrigerant tables, and ammonia tables. Steam tables, refrigerant tables, and ammonia tables. The specific enthalpy is entropy unit is kilojoule, kilogram, Kelvin. And the value are given relative to an arbitrary reference state. In the steam table, the entropy of saturated liquid at references state for steam table temperature centigrade is given value of 0 for many refrigerants. The entropy of saturated liquid at T saturated liquid for refrigerant T saturated liquid centigrade is assigned the value of 0. In general, we use the term entropy to refer to both total entropy and entropy per unit mass. Since the context, appropriate symbol will clearly indicate the precise meaning of the term. In the saturation region, the entropy may be calculated saturated region, the Entropy can be calculated using the quality. The relations are similar to the specific value and internal energy, and also enthalpy, which say that S, for example, 1 minus quality is F plus X is G. And also we can have another relation that S has a property is F for a saturated liquid and X is Fg, where Sfg equals to Sg minus Sf. The entropy of compressed liquid is tabulated in the same manner as the other properties. These properties are primarily a function of the temperature and are not greatly different from those from saturated liquid at same temperature. Table 4 of the steam table, which is summarized as table B14. Give the entropy of compressed liquid liquid water in the same manner of the other properties. The thermodynamics properties of a substance are often shown on a temperature entropy diagram, on an enthalpy entropy diagram. So we have various diagrams: temperature, entropy, temperature, entropy. And also enthalpy, entropy. Which is also called Euler diagram after Richard Euler of the Germany. Richard Euler. This is also Euler diagram. This figure provides the temperature entropy diagram. Temperature, and entropy diagram for steam. The general features of such diagrams are the same for all pure substances. A more complex temperature entropy diagram for steam is shown in the appendix E. Anyway, we have also a diagram for enthalpy and entropy as this picture. In the temperature entropy, we have also a saturated area. This area between this area is saturated area. We have quality of Q x equals to 0 and in this line, and critical point at the top of the diagram. And also we have a saturated vapor, quality is 100, and also a 990% quality also illustrated in this picture. We have superheated vapor. At pressure, for example, we had specific values, and the values were entropies. The enthalpy entropy Fourier diagram also shows in this picture critical point and the various quality lines, saturated vapor and saturated liquid. Anyway, for the better diagram is available in figure E1 in appendix E. This diagram is valuable both because they present thermodynamics data and because they enable us to visualize change of state that occur in various processes. As our study progresses, the student should acquire facility in visualizing thermodynamic process on these diagrams. The temperature entropy diagram is particularly useful for this purpose. For most substances, the difference in the entropy of a compressed liquid and a saturated liquid at the same temperatures is so small that the process in which liquid is heated at constant pressure nearly constant with the saturated liquid line until the saturation temperature is reached. Consider these two pictures. If water at 10 megapascal is heated from 0 degrees centigrade to the saturation temperature, it would be shown by the ABD. Consider these two pictures. In the part B, we have A, B, D, A, B, D diagram, which constant with the saturated liquid line. Zero temperature, we have the diagram 2B, saturated liquid, and two-phase liquid to the superheated vapor and to the saturated vapor and goes to the superheated vapor without increasing the temperature. In 1 megapascal and 10 megapascal we have different. For the high pressure we have also compressed liquid. We have only compressed liquids with these diagrams. The critical points also are in these points. The next section is entropy change in reversible process.